Good morning dear students. In the previous class we have seen one of the natural phenomenon, that is formation of rainbow. Natural phenomenon which occurs in nature, okay, because of presence of light. That is one of the phenomenon of rainbow formation. In today's class we will study one more phenomenon, that is scattering. Because of scattering of light, several phenomena takes place in the atmosphere, that is white color of cloud, then blue color of sky, similarly reddish color of sky during sunset or sunrise. So these are the phenomena. The main reason is for that is scattering of light. Okay, how does this phenomenon occurs? Okay, when a ray of light enters the atmosphere, okay, these rays, when the sun rays enters the atmosphere, these rays passes through the atmospheric particles such as atoms, molecules present in the atmosphere. So these atoms or molecules absorbs the sun rays and re-emits the light which has been observed in all possible directions. So if sunlight enters the, I will consider only one molecule, okay. If sun rays enters the one of the molecule or the atom which is present in the atmosphere, okay, what happens? Initially it absorbs the incident light and finally it re-emits the ray of light in all possible directions. Here the molecule or the atom which emits the light or scatters the light in all possible directions, it is called as what? Scatterer. Okay, it is called as what? Scatterer. And this light which emits, it is called as scattering light. Scattering light. Okay, so in order to occur this phenomenon, the main condition is that the size of the molecule should be very very small when we consider the wavelength of the emitted light or the wavelength of the scattered light. So for the scattering phenomenon, so here in order to get the various colors in the atmosphere, what happens? So when this scatter absorbs the sun radiations and it re-emits of color of various wavelength, okay, possible only when size of the molecule will be very small. Nothing but here, in order to occur that phenomenon, it will satisfy the Rayleigh's law of scattering. main we are having one of the optical instrument, that is our eye. You have studied the functioning of eye in your high school level. Okay. So here optical instrument has been used in order to see the microscopic objects. Okay. Optical instruments. So microscope, simple microscope or compound microscope has been used in order to see the microscopic organisms. Next, one of the optical instrument is telescope, that in order to see the far distance celestial objects present in the sky or in the universe. Okay. So I will define some of the term here. I think you have known this term in your high school level. Near point, far point. Next, least distance of distinct vision. Near point, far point, least distance of distinct vision. So for the normal person who is not having any defect in his eye, for him near point will be, so the minimum distance up to which for the observer eye the sharp image will be focused in his eye, that near point, the minimum distance. If we keep our hand in front of eye up to certain distance, we can see the complete position of our hand. If I bring it nearer, that range decreases. So that minimum distance up to which we can see the clear sharp image, that is nothing but a near point. For the normal eye, that value is of 25 centimeter. In order to get the clear image, sharp image, the minimum distance from our eye, it should be of 25 centimeter. Okay. Next, far point, we can see at some extent up to say infinity. As distance goes on increasing, the size of that will be decreased. So we can say our far point, the maximum limit of our eye is up to infinity. It's only for the person if there is no any defect in his eye. Okay. Next, least distance of distinct vision. Least distance of distinct vision. So for this notation D. Okay. So least distance of distinct vision for the near point, exactly it is 25 centimeter. Or we can also define it's the difference between the range of between far point and the nearer point. It's the range between or the difference between the far point to the nearer point. Okay. So this term I am going to use in the while explaining the simple microscopic concept. Okay. So got the point, what do you mean by near point, far point and least distance of distinct vision. So this is also said as range of the vision. Okay. Next, first one of the type of the microscope, that is simple microscope. So I think you have already seen the simple microscope. In order to just see the magnified image of the microscopic objects. Okay. There will be a single lens. Okay. Which acts as objective as well as a eyepiece. Okay. What happens? So in case of simple microscope, okay. In case of simple microscope, the object will be between the optic center and the principal focus. Within the optic center and the principal focus of principal focus, image will be virtual, erect and enlarged. ಯಾವ ಸೈಡ್ ಅಲ್ಲಿ ಆಬ್ಜೆಕ್ಟ್ ಇದೆಯೋ ಅದೇ ಸೈಡ್ ಅಲ್ಲಿ ನಮಗೆ ಏನು ಕಾಣುತ್ತೆ, ಇಮೇಜ್ ಕಾಣುತ್ತೆ, which will be in the enlarged form. Okay, I'll consider one simple lens. Let f be the focal length of the lens. Here f is the principal focus for the lens. I will keep the object between optic center, exact center of the lens. Okay, one ray passes through the, if the ray, incident ray is parallel to the principal axis, after phenomenon it passes through the one more principal focus of the lens. Another part of that, if one ray passes through the optic center, then it will be undeviated. So ಇಲ್ಲೇನಾಯ್ತು, ಇದರಲ್ಲಿ ನೋಡ್ತಾ ಹೋದ್ರೆ ಇನ್ಫಿನಿಟಿ ಹೋಗ್ಬಿಡುತ್ತೆ, ಹೌದಾ, ಅನ್ಪ್ಯಾರಲ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. So here, in order to obtain the image, we have to construct the emergent ray line in the, extend the line in the backward direction until where it meet. Okay, so here I got the image. If AB is the object, A dash, B dash is the magnified image of the object. Okay, so you know that of linear magnification. Similarly, in case of microscope, we are going to define the angular magnification. Okay, that is this case for the distinction case when the object is at the near point. Okay, so this is our, so this much portion is the object distance and it will be our image, nothing but the least, for normal adjustment it is least distance of distinct vision. Okay, image will be formed, this distance will be our d value. Next, angular magnification m. Okay, if I shift this object over here, okay, illidre, this total value is beta and this value is alpha. Okay, so angular magnification can be defined as the ratio of the, here is our eye, through which we can see the magnified image. Okay, so angular magnification can be defined as the ratio of, it's the ratio of angle subtended at our eye, it's the ratio of angle subtended at the eye by the image. So angle subtended at the eye by the image, the angle is beta, to that of the angle subtended at the eye by the object. When when both object and image, okay, imagine that both object and image will be at the least distance of distinct vision, we adjust in such a way that we will get the angle beta and alpha when our object and image will be at least distance of distinct vision. Okay, here since It's the ratio of the size of the image to that of the size of the object. Okay. If we rearrange everything in terms of image distance to that of the object distance. Okay. So here image means D, object U as it is. So I can write D by U. Okay, I can write D by U. So directly I will write by using lens formula. Okay, I can replace this value, that is 1 by f is equal to 1 by v minus. If I use this lens formula for 1 by v, I will get the value. Derivation is not derived by it directly. Magnification value, angular magnification of the simple microscope for the distinct vision, that is 1 plus d by f. It will be 1 plus d by f. 1 plus d by f, d is the least distinct vision and f is the focal length of the lens. Next, if I do some adjustments such a way that the object will be displaced to f. Okay, for normal vision, that is for far point, if I by doing this adjustment, this object will be shifted to f. If object is at f, you know that image will be at infinity. So I will write the magnification value, or I will get directly 1 less than this value, that is simply d by f. That's the angular magnification value for the normal vision, and it's the angular magnification for the distinct vision. So here we can simply magnify the image. Okay, in order to get high magnification value, high resolution value, so we are shifting it to the compound microscope. Okay, so compound microscope consisting of two lenses. Okay, compound microscope consisting of two lenses. One lens is objective and one more is eyepiece. You can see here. Okay, so in this diagram, it is the objective of the compound microscope, below which object has been placed. Okay, and it is the eyepiece of the microscope through which we will see the image. Okay, so here the focal length and the aperture of the objective will be very small when we compare it to the focal length of the eyepiece. Okay, so focal length small, aperture small, objective here. For eyepiece, focal length will be large as well as aperture will be large. Okay, what happens initially, the object will be below the objective lens, that is here object will be between the f and f0. So f0 means principal focus for the objective, f0 beyond the f0. When object is beyond the f0 of the objective, when ray passes through the lens, after phenomenon what happens, it finally converges at a particular point, will get a real inward enlarged image. See here, AB is the object, the image is obtained in this position, A dash, B dash. It's the first image, that is the image of the objective. Next, for the eyepiece, this image itself acts as the object. Okay, for the eyepiece, this image itself acts as the object. So here the object will be between the optic center and the principal focus of the eyepiece. Between the optic center and the principal focus of the eyepiece, once again this eyepiece acts as a simple microscope phenomenon. So finally you get a enlarged image, virtual erect enlarged image for this object. For the first object, it will be a real inward enlarged image. That is how the compound microscope works. Let's see. Directly I will write image distance of the object